The hottest things in the universe aren't made by lightning or volcanoes or even stars or supernova. They're made by humans. As humanity grew from cave dwellers to the spacefaring explorers of today, we've been constantly limited by our technology. Humans are builders. We build weapons to hunt prey and tools to harvest crops. And then we invented tech that lets us build even better technology, like the steam engines that launched the Industrial Revolution and the circuit boards that launched the digital revolution. These inventions are the ones that people normally focus on, but most people don't focus on a more fundamental trend that underpins all of them: the human ability to harness energy. We couldn't build harvesting machines and steam engines until we could smelt and mold metal. We couldn't build rockets until we synthesized rocket fuel. And we couldn't build fusion reactors without incredibly high-powered electromagnets. All of these things require energy. And a simple way to think about energy is to think about heat. Technically, yes, heat is just wasted energy. But because it's really confusing to think about joules and everybody understands degrees, I think we should start there. A brief history of the hottest things on Earth is not a bad approximation of how humans have learned to harness and use energy more effectively over time. Humans first harnessed fire about 1 million years ago, starting with friction and then moving on to flint and pyrite. Simple fires are easy to make. You use the oxygen from the atmosphere, fuel from organic matter like trees, and a spark. Ignition from the spark leads to combustion. The oxygen steals electrons from the fuel, oxidizing it, and releases energy and heat in the process. Fire gave huge advantages to early humans. It gave them warmth in the winter, protection from predators, vision in the dark, and cooked food. But it was only the beginning. Soon, humans learned how to make their fires even hotter, to contain them. The simplest furnace is just a pit that you put a fire in. If you capture all of that heat, rather than it escaping into the ether, it is turned back on itself, capturing energy and combining it with more of those combustion reactions to turn it into higher and higher heats. But there's a problem with the simple pit design. There's no way to get enough oxygen down there in order to react with all the fuel. Chemical reactions require precise combinations of molecules. If there's some fuel that can't find an oxygen as a partner, then it's just lost and released as soot into the atmosphere. The solution is to take the hole and build it above ground, a kiln, which lets air flow through more naturally. These hotter fires allowed us to first shape and then smelt the first metals: gold, copper, and iron. All three of these were found in nature, and copper was the main character, both by itself and melted together with tin to form bronze. Copper made weapons and hoes and sickles and plows, and bronze is basically just better copper. It's harder and stronger, it resists corrosion, and it can be molded more precisely and simply. The Bronze Age was when cultures in Mesopotamia and Egypt first developed writing systems, and they started organizing into larger civilizations. Humans in this era also built the wheel, canals for irrigation, massive monuments like the pyramids, and even the first sea-going boat. But bronze is nothing compared to iron. People even knew this back in the Bronze Age. Iron is super bronze. It's harder, it's more stronger, it can hold a sharper edge, and it's more abundant in the Earth's crust. But there's one problem. In order to take the abundant iron ore that is already in the Earth's crust and turn it into usable pure iron, you have to have incredibly hot temperatures, way hotter than 1100 C, which is what these kilns could produce. And therefore, the only place that you could find purified iron in the Bronze Age was from literal asteroids that had fallen from space. Eliminating our dependence on iron that came from space was something that we only did by taking a massive step forward in our ability to capture energy, which we did with Bloomeries. A bloomery is basically a furnace with bellows that can force more air in there and make more oxygen available for combustion. It's basically solving the same problem as taking your furnace and putting it above ground. You're allowing for more air, but it turns out that even those above ground kilns still needed more oxygen. The only way that it could happen is by forcing the oxygen in to react with the fuel. Bellows were originally made with clay and animal skins, and once they were popularized, they started the Iron Age. And that's the best technology that we had for the next couple thousand years. Modern blast furnaces work basically the same way as a bloomery. We construct a massive above-ground pit, we feed fuel inside, extremely strong jets blast oxygen into the fire, creating a high-efficiency reaction and an extreme amount of heat. By controlling the ingredients that we put into those blast furnaces, we learned how to make steel. And once Sir Henry Bessemer learned how to take that process and make it extremely efficient, steel built the modern world. We use steel to build cars, ships, and planes. Also skyscrapers and bridges and railways, and soon we'll use stainless steel to build spaceships. But before we get ahead of ourselves, we need to talk about another invention, one that was way hotter and actually used a different source of heat than any of the fires that humanity had previously controlled. That source of fire is the sun. It burns at 5,500 degrees Celsius, and by harnessing it and using the electricity that resulted, we were able to take a massive leap forward. We'll talk about the sun and electricity and heat in part 2 of this video, which is coming out very soon. If you want to check it out, I recommend that you subscribe and throw this video a like.